Hello everyone. So this is a quick tutorial on how to do simulations, and to be precise, Monte Carlo simulation that is used in a lot of risk-based analysis. So I'm going to first, if you wanted to follow along with me, this will be exactly the lab directly from week 5. But I wanted to show you something new so that the concept gets a little better. So I wanted to start with Excel because this is what we see on a normal basis. Excel is quite prevalent, and it also probably helps you understand the math behind the Monte Carlo simulation. So Monte Carlo simulation essentially is based on a casino, Monte Carlo. And the idea is that if you knew distribution of the data, if you knew how data looks like, and if you randomly choose certain values or parameters, can you technically guess a number of things? In other words, like for example, think about it this way. Let's say you go to casino multiple times, and it looks like on average you win $5,000. The standard deviation of the data is, let's say, 50. And if you go to 20 times, how many times do you actually end up winning? Is it 9? Is it 7? Is it 8? And because there's always going to be random factors, because there's no guarantee that you'll always win all the time. So what Monte Carlo simulation does is we can simulate going to casino millions of times, let's say 1 million times, and perhaps look at it from that point of view and say, okay, if I go to casino millions of times, or a million of times, maybe I am going to be incorrect 400,000 times and correct 600,000 times. When I say correct, make money. So that is the essence of Monte Carlo simulation. You are kind of looking at risk from a very big, broad point of view, or more trial. So I'll start with an example, and then I think it'll make more sense. And we'll go to the Jupyter notebook to um, kind of apply the stuff that we learned here. So think about. So I'm going to, if you watch my Excel, I'm going to create a hypothetical company called York Data Corp, and essentially it's just a random company. And at York Data Corp, it is in a business of starting or providing data science related lectures, and it generates some sort of revenue. So when we look at the revenue from that perspective, perhaps we have some historical data, and a lot of our analysis is based on historical data. And based on the historical data, maybe on an average, this is the accounting reflection of the business. So what I mean by that is maybe there's revenue that we generate through this company. Maybe there is some fixed cost, and maybe there is also some variable cost. I mean, you could model it as you want, right? So I mean, we're assuming here that your Data Corp has been operating for a number of years, or even if your Data Corp was not there for a lot of years, what we could assume, we could get data from comparable company like York Data, and then try to find some analysis. So when we did that, we found that on an average, the revenue of companies like York Data or York Data is, let's say, I'm just throwing numbers out there, $50,000. It creates revenue in a yearly basis. And you have to, pay that staff, let's say that is about $25,000. And let's say the variable cost is like $1,000, for example, right? So these are just random. I mean, there's you can do it for any other stuff, but essentially these are your cost. And the historical cost can also give you standard deviation. So if you had multiple different data points, perhaps the fact that you found average or mean, you can also get standard deviation. And these are things that you should are given. Without these, you won't be able to do like Monte Carlo simulation. So I'm randomly throwing out the standard deviation, perhaps is like 500. This is 200. And let's say this is 700. I'm just throwing numbers out there. So when you are given data like this, there are a few things that are given to you, or at least you should kind of figure it out what distribution it is, right? because based on the distribution that is of the data, our analysis will be a little different. In our case, let's assume that standard deviation. In most cases, you will be encountering standard deviations anyway. So someone said you're starting a new company. Once again, your data corp, and the average revenue generated by companies like your data was 5,000, and the cost was 25,000 fixed cost, and the variable cost was 1,000, and the standard deviations were 500, 200, and 700. And you tell me, is this company going to be relatively profitable or not, right? So what we do here, and if you think about it, like the profit is always going to be revenue minus fixed cost minus variable cost. That is just the way we do it. But you could also add multiple different variables as well. So the trick here is Monte Carlo simulation. So I'm going to put it here, Monte Carlo simulations. And let's say it is first simulation, first sim. Okay. So what Monte Carlo simulation does is, let's just focus on the revenue column, like 5,000 and 500. Okay. So the revenue could be 4,900. The revenue could be 51,000. Revenue could be 48,000. It could vary, right? Like it's not always going to be 5,000 because 5,000 is just a mean. So what Monte Carlo simulation is based on the mean and based on the standard deviation, it will project a simulated value or hypothetical value. Okay. So by that value, you'll be saying, okay, based on these two variables, can you give me a value that is random in nature, but kind of agrees to this distribution here? And when you do that, you're given a value and you can simulate it millions of times. So the standard deviation bounds the projection, and the mean also bounds the projection. So it won't really be like 100,000, or it won't really be like 5,000, right? It will be somewhere close to the 50,000. So the formula for that is, you go in here, formula bar, you go, you go equals, sorry, you go equals here, and and then what you do here is you do, we're assuming it's a normal distribution. Sometimes it could be uniform and for exponential. So decide, Excel has some built-in stuff. So normal dot inv, okay. And what we're saying is, find a probability. So there are three variables is asking you for to generate that. And once again, I'll reiterate the messaging is that, once again, we are trying to simulate the first value or guess the first value based on historical data, which is saying $50,000, and standard deviation is 500, and guess a probability. In this case, we don't know the probability. We cannot explicitly tell the probability. So we'll use something called random. So what random function does is it chooses a value between 0 and 1. Remember the probability. And it will say, okay, just choose a value. And then based on this value, and based on the mean and standard deviation, give me a value that's closer to here. And in other words, that will be your first simulation. So what we'll do here, you choose this guy here, and we'll do comma, and this guy here, and comma, and we'll hit enter, right? So like I said again, like, I'm just gonna do it like this here. Just gonna make sure that it's aligned. So this way. So if you see, it gave a first simulated value of 50,688. So this is historical data, and it is telling you that if you run the business first year, it is going to give you 56,000, 50,000 and change. So it is bounded. So we can do the same thing for all of these guys here, and the fixed cost. So now you can look and you can guess that, based on the historical data, looks like the first simulation is telling us that it is going to be profitable. So let's do equal revenue minus this guy minus and this guy. Looks like, based on our risk management, looks like our company is going to be profitable around $22,000. So once again, let's reiterate. You're given this value, revenue, fixed cost, and variable cost, and you're also given corresponding standard deviation value, and you simulate it the first instance using this function here, norm.inb.random. So when you do that, it's telling you that based on these characteristics of the data, give me a number that appears. So it will be always bounded. So you create first simulation, right? Fantastic, excellent. But is this enough? We already had this, but the beauty about the Monte Carlo simulation is you can simulate as much as you want. And why is that important? Because the more data point you have, the better, right? So how do we do it? I have a little Excel trick here. So you can do something called simulation trials, whatever you want to name it. Okay. And how much do you want to simulate? Do you want to simulate, 5 times, 6 times? Do you want to simulate like 1,000 times? It totally depends on you. Oops. So if you notice every time you hit enter, the value is going to change because every time it is going to give you, let me see if this works. There you go. So let's say up to 10 simulations, and typically you would do 1,000, 50,000 and so forth, but I just want to save some resource here, right? So the first simulation gave us the profit of 24,000. So we can do equals and you can do 24,000, boom, right? Perfect. So how do you simulate, profits here? Okay. So how do you simulate, this option here? So you can just copy this entire table, 2 columns, and then you go to data, and you can do what if analysis, and you go to data table, click on the column input table here, come outside and hit OK. And obviously something's off here. Let me do that again. Okay, so you just copy this value. This is boom. And you go here, what if analysis. And oops, first cancel this here. So data table, you come here, you do this, and then you do, there you go. Something off was there. So if you look at it here, I'm gonna like make sure that it's clean. Okay, looks like based on this value that I was given, looks like when you did 10 trials, looks like the company is going to be profitable. So you can do risk management that way, right? So what you can also do is you can just look at the entire column and see if you can find negative returns there. I mean, if it's just 10 data, I can say it's zero. It's zero. But in some cases, you can also use functions like count and count if. I'm not an Excel guru, but you can just do the range here and comma. And we want to see if there's anything less than 0. And if there's anything less than 0, it will count that, right? So hit enter, 0. So obviously there's none. And sometimes, you want to figure out the risk percentage of this particular item. So you want to see how risky it is. You can also do something like, first of all, this is 0. And you can do something like this, right? So divided by, and then you can count the rows, right? You can count the rows based on this guy here. So, it looks like the risk percentage is 0, right? You can play around with this value. Let's say if this is 15,000 and let's say the fixed cost 12,000, a lot of standard deviation means a lot of variation data. And let's say it is almost 950. And it looks like if the standard deviation is further out, there's more risk to the business because something is unknown. So you can do the same thing, excuse me. You can go here all the way. You can do more simulation by going to data. And you can just do data table, come here, do boom, and there's more simulation. And as you can see, this guy is going to obviously then cover here L11 to L25. So let's see if, okay, so looks like there's a lot of negative values coming around. Risk percentage, L25 here. Okay. So there's about 16% chance your business is going to fall. So you can run it to millions of data. So, when you do it in Excel, it'll be time consuming, resource intensive, but obviously you can do it. So again, Monte Carlo simulation is just a simulation based on casinos theory. If you have the data, historical data, you can start assuming. And in this case, if someone asks you to run like, about 20 different odd or 25 simulations of the business, you can tell that the risk of business folding your data corp is about 16%. So once again, I just wanted to give you a glimpse of on from Excel side. Now we'll be pivoting to the notebook and we'll see how it works.